Okay, so welcome to the 11 a.m. class. Let's start, everyone. And please don't ask distracting questions in chat because I am kind of viewing that on the side and you're distracting everybody. So please keep your questions along the calculus. If you want to ask questions about the new Rick and Morty show, sure, would you please ask them in general chat so that it's not everybody seeing it, in particular me, but everyone else. It's a little distracting. Um, anyway, let's. There. So, inappropriate checks, now delete it. Talk about them in general. I want you to build community. I want you to talk about the Rick and Morty chat. Believe me, I want that. But please do it outside of the class chat. By all means, do it, but do it outside chat. Anyway, there was a question about all quizzes. Yes, all quizzes will be on Proctorio. So let's talk about that. Let's talk about the quiz first. Okay, so how's Proctorio first experience? How do we feel about Proctorio 1 to 5? Just Proctorio 1 to 5. How do we feel about that? Yeah. Okay. So I basically spent like 4 hours longer of my life on Sunday, which I will never get back, getting that thing to work. So if you are in the Proctorio, I Hate Proctorio fan club, I am there as well. I'm going to have some t-shirts printed out because, yeah, Proctorio is awful. Now, there's been some concern and some stress about Proctorio, so let's go over it real fast. The idea is that we ensure the integrity of the test. So, and I talked about this more at 9:30, so you're welcome to go review my 9:30 stream because I'll probably say slightly different things. But the idea is that you point your webcam at your working place. And I would go, if you want to, go over to Walmart. This costs like, it's a stand with a light. It cost me like, I think it was $20. I made a DocuCam out of this one with an old cell phone, as you can see. But you can use this to like mount your webcam somewhere other than to the top, because otherwise it looks down at you. It's very awkward when using Proctorio, and it's kind of, Proctorio is a little creepy. Here, install spyware on your computer so that we can spy on you. Yeah, it's a little creepy, but it's kind of the tool we have. So given that and this emergency, I know that there's things upset. A couple things though about Proctorio. Yeah, so you keep the camera on yourself and your workspace. So Proctorio has this algorithm that looks at your eyes, it looks at your face, it looks at the thing, and we want you to do this thing where you hold up the pages so that we can have an honest, system where we're not accusing people of cheating. Now, it's important to note that Proctorio does not accuse you of cheating. Proctorio flags things that look funny. Now, the reason why we set up the quiz the way we have, where you're on one quiz question while you do the quiz or test, which is the test is going to be structured the same way. And again, this is a learning experience for all of us. But the way that we're going to have it is so that we can quickly distinguish, we can toss flags. Like when you pick up your cell phone to take your pictures, Proctorio is going to flag that. And if you've done it in the next question, we know right away not to review that video. But Proctorio does not accuse anybody of cheating. Proctorio says, okay, there's something that should be reviewed. Okay. So what happens is it prompts us to do the review. We go on and we say, okay, we look at it normally. So that the we look at it again. And so we want the webcam to see your workspace and all, and that's going to mean some adjustment for your webcam. If you've got issues with this, we can talk about it. I'll be happy to talk to you about it one-on-one in voice chat during office hours. I'll be happy to talk about it on Discord. I actually prefer you talk about it on Discord because you answer each other's questions. And we can talk about it over email. I'm more than happy to talk about Proctorio and all of the things. And this is going to be a learning experience for me, a learning experience for you. We're not trying to be a jerk about Proctorio, right? This class was not designed to be online only. All right, it was designed to be the tests were designed to be taken in a large auditorium. And we're going to simulate that as much as possible. Now, yes, we have to use Proctorio. I hate Proctorio. You hate Proctorio. The American people hate Proctorio. Everybody hates Proctorio. And I'm going to review these videos myself. But again, the Proctorio system cannot accuse you of cheating. All right, it can accuse you. It can say, "Hey, why don't you look at this?" And then I can accuse you, or the TA can accuse you of cheating if there's something funny really going on. But the bar is going to be kind of high on these things. Okay, this is not a class which we designed to be online. This is a class that was designed to be taken in person. Okay, so if you write the quiz by hand and go to the quiz PDF to look at the thing, right? Proctorio is going to flag that. Now, what are we going to do when we say, okay, review this? We're going to see the title of your thing, your tab was, and one of the advantages of using Chrome is that Chrome opens PDFs in Chrome. The title of your tab is going to be the quiz name, right? And we're actually going to see on your tab the quiz pulled up. And we're going to go, yeah, that's what it should be. Now, one of the things that's come out of this, we're probably going to change procedures a little bit as the time goes on because, it's a learning experience for you. It's a learning experience for me. It's a learning experience for all the calc instructors, basically all the instructors, because we never intended these things to be used. We have no idea, we have some idea of what we're doing, but, and we're going to be a little flexible. Okay, so again, Proctorio doesn't accuse you of cheating. Proctorio says, look at this. Then one of the TAs goes on and says, okay, look at this, right? The TA goes, no. Scott, you look at this one little thing. And then I go on and I say, no. Or I say, yeah, that's kind of suspicious. Let's talk to the student. So again, Proctorio does not accuse you of cheating. It flags behaviors that it says are, why doesn't a human look at this? Okay, does that make sense? So as I said, it's going to be a learning curve for us all, and part of the reason for doing it right away is so that we can learn what goes on with Proctorio. We're going to do this 5 times before the test, right? We have 4 quizzes, including today. We got a bootleg. I'm going to figure out a way to do makeups with Proctorio because I want to do them. But as I said, this is going to be a learning curve for you, learning curve for me. What we're thinking about the test, and we're having so we wrote the test yesterday. We finished rewriting it. It looks longer than it is. We're talking about giving you more time because we can now, because we're online, right? We don't have barbarians at the gate knocking at the door. So we're talking about giving you more time to do it. But it is going to be just like the as much like the auditorium as we can, okay? So the quiz is going to the test is going to start exactly at 9 a.m., 8:55. We'll unlock it manually, okay? And then you're going to have maybe longer, maybe shorter. We're going to want I want everybody to log into Discord, log into an audio chat while you're doing it. Now, 2 reasons for this. One, it lets you ask questions, right? So if you are in the audio chat, and then there'll be a room called Raising My Hand in Text, right? And then I'll pull you aside, and you can ask questions for me just like it was a normal test. Okay, and there'll be proctors and everybody there. Also, if something happens with Proctorio, you raise your hand and we deal with it. All right, so that we're going to have contingencies in dice. If you have particular what-if questions, by all means, ask them. I'm not going to answer them all now, but I still want you to ask them because we're having a big meeting with all the calc instructors this evening to actually talk about that. Okay? So 1 to 5, how do we feel now, comfort level about this Proctorio idea? 1 to 5. Okay. Again, I don't want you to be worried about Proctorio. I want you to be worried about the test, not the test proctorer. Okay? Stress about the test, a little bit of that's okay. Stress about Proctorium, no, I don't want that. I don't want another distraction, right? I want this to be as much as possible seamless for you. Now, it's not as possible, right? I mean, it's not, I can't ensure a quiet environment at your home. I can't ensure that your sister's not going to wake up and start blaring Led Zeppelin. Now, if your sister wakes up and blares bad music, we're going to have an issue. If she starts playing good music, we'll let it slide, right? But it's going to be stuff like that is going to happen, and there's nothing, as much as possible, we want to make this like it was for taking an exam in an auditorium, which is also going to mean if you want to go use the restroom, get into the raise my hand chat, and raise your hand. And then we'll deal with that, right? We'll say, okay, yes, go to the restroom. We'll make a note of it on our page that when Proctorio flags you, you ask to go to the restroom, right? Just like it would be, you ask a TA, can I go to the restroom? And the TA says, fine. Calculators, we're trying to work that out on Proctorio. Proctorio includes a calculator. We're not sure if it's done. It will be free response. There won't be true, false, multiple choice. We talked about doing it. But we didn't. We decided in the end we're going to make it just like the tests are. We're going to make it because it's not a terminal class, right? Calc 1 is not the end of the reg. You've got Calc 1 as a prereq for all these other classes, and especially all your science labs and stuff like that. So you need calculus. So we decided not to make the course easier. We're trying our best to give the same level of rigor remote. Whether or not that's possible is open the question, but our goal is to deliver the exact same content with the exact same level of task. Now, granted, we did change the test a little bit, right? And we're going to probably give you a little bit more time to take the test than we would have otherwise because we know that there are distractions in all this. So if you have any more questions, yeah, so Discord on the again, if it flags Discord, we're fine with it. We're going to put it in an exception, right? We're going to put a Discord tab or the Discord program as an exception to Proctorio. And all of these things, I don't know how they all work, and that procedure may change, but that's the goal. The goal is to make it just like the test as much as possible, just like sitting in a big auditorium as much as possible. We might not succeed, but that's our goal. Okay. Any other questions about that? And again, don't get stressed about Proctorio. I'm going to give you feedback on the quiz. I'm going to watch the Proctorios, and TAs are going to watch the Proctorios. We're going to see what's going on. The test will be exactly the same. So at 8:55, at 8:50, everybody should be in Discord on chat, ready to go with their computers cleaned up, looking at their notes at the last minute. And then at 8:55, if everyone's here, we're going to start. We're going to give you as much time as possible. Then when when time is up, the fat lady is going to sing an audio chat. All right, it's going to be as much as possible. If you want to turn in your quiz test, there'll be a channel. Turn in the test, and I'll be sitting at it. Did you answer every question? Did you? Did you answer them all? Did you answer them all to the best of your ability? I'm going to make it as much as possible. Now, I can't force you to sit down like I can. I can't give you the whole professor look if you try to leave early during the test, but I'm going to try. I'm going to have a little gift, right? I don't know exactly how I'm going to give you the professor look to make you feel guilty about trying to leave the test without answering everything. But I'm going to figure out some way to do it. Okay. So the test will be given. So it's a good question. The answer sheet is going to be given to you a week in advance. Now, you can do it on blank paper. The hard problem to do, so we're going to give you the answer sheet a week in advance. So the hard part of that is going to be to do the paper, the graphs. There's just going to be 2 graphing questions on there. Short, easier graphing questions, definitely easier than this quiz. But when we do that, we're going to, so you can do, those are going to be kind of tricky to do up by hand. You're going to have to like hold up the page to the thing and do it. But we're giving you the answer sheets a week in advance to print out, okay? And then when it comes to test time, you click on the test and the questions will appear, okay? So you'll be given the test at the exact same time as normal. But you'll be given the answer key way in advance. So that you get, not the answer key, the answer sheet. So the sheet that we want you to fill out answers, scan, and then submit will be given way out in advance. More forgiving on the test. We'll talk about this again. I don't want to stress you out about the test. I want you to stress you out less about Proctorio. We'll talk about the test as it gets closer, and I'll be happy to help you with that. There won't be so you're going to have the screen up for that. You'll have the screen up for Discord. We haven't figured out exactly how everything's going to work yet, but we're trying. And the point of Discord is it's supposed to be audio chat. So the only reason to actually change from Discord, the only reason to flip on Discord is if you to change from the regular chat, the chat room, to the is if you want to raise your hand and ask an issue. And it's going to be the same thing as possible. You want to go get more scratch paper, raise your hand, we'll come talk to you. You can go get more scratch paper, et cetera, et cetera. We're going to try to make it as much like taking a test in the auditorium as possible. No promises on success failure, but that's what we're going for. All right. Any other questions about that? I don't want to spend any more time on it because I've started 5 minutes late and now I've yacked for 15 minutes on the testing procedures, and I don't want to do that. I want to get back into the math because that's the part that's really hard for the test. Any other questions? And the part we're actually here to learn, heaven forbid. Okay. So there are people asking more questions in chat, and that's fine. You may ask them, but yes. So we'll talk again. We'll talk about the laptops. We'll talk about making it work. We're going to throw some experiments together. We're going to see what we can do. Okay. I don't want you stressed about Proctorio. I want you a little bit of stress about the test, not about Proctorio. Okay. So 1 to 5 now. How do we feel about Proctorio? More importantly, 1 to 5, how do we feel about this idea that Proctorio cannot accuse you of cheating? Okay, it can flag things, but it cannot accuse you. So the machine is not going to give you a double F. Okay, it's going to be. We're going to actually have to talk to you. We're going to have to review the footage and talk to you and review all the things about Proctorio. And again, if there's a Proctorio emergency, one of the reasons why we're all going to be at Discord, you can raise your hand. You've got an emergency with Proctorio. We'll have contingencies in place to deal with it. Okay. So yes, Proctorio is, but it is what the tool we have. Okay. For some of these tools, I can cheat, like I can get away with using Discord. And then the bootleg is going to be a Proctorio quiz. It's going to be just like the exam. It's going to be a Proctorio test. I'm going to give you the bootleg in advance. I haven't written it yet. Normally, I would have written it last weekend, but I didn't have time. We were futzing with Proctorio. As soon as I can get it written, I can. Also, WebAssign is up for tonight. There's no WebAssign due tomorrow. There will be a WebAssign due Wednesday. I'll also post the quiz hopefully today or early tomorrow morning for Wednesday. But I haven't gotten there yet. Okay. I'm sorry I don't have more answers for you, but it is what it is. There's only so much I can do. All right. Any other questions, comments, issues? Okay. So let's stop talking about this and let's actually talk about the material like we wanted to. Okay. So that was question 1. Question 2, state Rolle's theorem. F defined over AB. If F is continuous, F is differentiable. Continuous on the closed, differentiable on the open. This is preamble. You don't need to have it. I know I used D last time. That's fine too. This is the picture associated with it, picture optional. The important bits are, of course, that this is a closed interval. that it's continuous over the closed interval and differentiable over the open interval. How do we feel about that, 1 to 5? Okay. I see your questions about the test breakdown sessions and the review sessions. Again, I'm going to try to make it as similar as possible. So yes, there will be the same information, but it's going to be basically already provided in the answer key anyway. So I'll talk about the answer key a little bit, and you'll have it in front of you, if that's your question. Okay. Again, I don't want to spend more time on the test. Okay. So we feel pretty good. And then the next one, of course, 1 to 5, how do we feel about the statement of the mean value theorem? This right here, f of b minus f of a over b minus a. I also said it, I think on the notes, I said it last time, f of a minus f of b over a minus b. That's fine. Both of those are the same thing. As long as b is on top of b and a is on top of a with a minus sign in between them, that's fine because it's the same thing as multiplying both the top and the bottom by -1, which is, negative 1 over negative 1 is simply 1, so you get the exact same answer. I'll even write that on here, right? Okay. You can say either one. It's the exact same statement. Okay. All right. Any other questions about that? Okay. Okay. So let's go to the next one. Next one's the graph, and this is not an easy graph. This is probably the second hardest graph that we're going to deal with the entire class. So let's talk about it. I have a lot of conditions, and I have not a lot of space because I did this, yakety yak at the top, and then I asked that question at the bottom. So there wasn't a whole lot of space here. But I've got a bunch of conditions. F is continuous. F is roots, places. It means roots. F has roots means what? It means that f of x equals 0, right? And then I've got these other conditions here. So if I've got roots, that means f of x equals 0. And then I've got these other conditions here, right? I've got decreasing, f prime of x is decreasing from -2 to 0. And I've got that it's I've got that it has two roots here. But I've got here that f prime of x does not equal 0 for any x in -4, 0. All right. So it looks like at first that this condition is going to violate Rolle's theorem, but it doesn't because I didn't specify that the derivative had to exist. Okay. So I wrote here as a note, can be kinky. So what I did to make that happen without violating Rolle's theorem is that I came down straight up, then I put a kink here, and then I came back down. So the derivative is never 0 because right here the derivative doesn't exist. How do we feel about that 1 to 5? Meeting 4 while allowing for 1 through 3. Right. So this is meeting 4 while allowing 1 through 3. Okay. All right. So that's a little tricky. The next one, however, is impossible. If I say that f of 4 has to equal 3, okay, and then I say that f prime of x here, if I say f of 4 has to equal 3, but I say that f prime of x has to be less than 1/2, I can't get there from here, right? The mean value theorem says that if this is true, then somewhere my derivative has to be greater than 1/2. Right? Somewhere my derivative has to be at least 3/4, okay, which is bigger than 1/2. So there are two things I could do. I could either circle this, okay, or I could circle this. If one of these conditions can't be met, I need to state it can't be met, and then I need to go there, okay? Now, this thing is way harder than anything that will appear on the test, right? The purpose of this problem, there are graphs on the test, there are 2 of them. The purpose of this problem is to nail home this idea that these are theorems and that I can't violate them. And part of my, evil intent, part of my evil intent was to have you sit there and play with it for 30 minutes trying to figure out how to do it. This was a problem that I wanted you to play with the mean value theorem. I wanted you to play with trying to figure out a way to do it without violating the conditions, okay? And that was its purpose, right? It was really a 30-minute homework assignment to sit there and bang your head against it, to kind of drive home this point. So this is way harder than anything that can show up on the test because, you don't have 30 minutes to do the graphing problem. But it is an important problem, right? I'm not torturing you for no reason. This was torture, but it was torture for a purpose. 1 to 5, how do we feel about this graphing problem now? All right. There will be one about the similar level of difficulty on the bootleg, but not on the test. This one's harder than the one that's on the test. But it is an important problem. Figuring out the reason why these things can't work is important. And then, of course, name one thing you found memorable. Okay. Any other questions about the quiz before I move on? Okay. Okay, so last time we talked about proofs by contradiction, which is, fun and everything. And we did the square root of 2 is irrational. I usually make that show up on the bootleg or something similar like the square root of 3. And they're all cool. But we don't end up, or the cube root of 2 is also a nice one, but we don't put them on the test. Those are number theory. If you take my discrete math course, they'll show up on tests. But here, or if you take bridge or something like that, they definitely show up on tests. But here, what we're doing is we're just trying to make the point. There's this famous theorem that says that the square root of 2 is irrational and that these numbers exist. And so we play with it. But the important thing is that proof by contradiction concept. And then we proved Roll's theorem using contradiction. Okay. Today, what we're going to do is we're going to do an example problem with Roll's theorem, and then we're going to show how to prove, using Roll's theorem, prove the mean value theorem. And that has a trick to it. And then we're going to prove this extremely important example thing, right? It says that if two different, it says, so it's rather obvious that if two functions differ by a constant, then when you take the derivative, the constant goes away, and you wind up with two functions that are equal. The derivatives are equal to each other if two functions differ by a constant. What's not obvious, what's more difficult to prove, is the other direction. Is to say that if two functions have the same derivative, then they're nothing but vertical shifts of each other. Then they can differ only by a constant, right? So one way is easy, but the other way is harder, and you need mean value theorem to do it, and we're going to do that one today. And then next time we're going to talk about optimization. I'm going to do a little bit of cleanup from stuff that we did in the back, but I'm actually rather pleased by the Web of Science, believe it or not, on section 4.3. So I'm not going to spend that much longer on 4.3, except to give you the problem set for this week has some questions on that. But I'm actually very pleased with how that's going. So I'm going to not spend as much time on 4.3 as I would have otherwise. Okay. So that's where we are. So again, let's look at Roll's theorem. This was the statement for Roll's theorem. Does anyone have any questions about where we're headed? So the idea is that we're going to jump into optimization as soon as possible, because there's definitely an optimization problem on the test. And then we're going to come back next week and we're going to we're going to do a little bit more L'Hopital's rule, which is a consequence of the mean value theorem. And then we're going to spend some time, and then we're going to kind of set up module 4. We'll spend some time doing something that's in module 3, but is on Wednesday, but is really for module 4. So, you'll get a little bit more practice in module 3, but it's really stuff for module 4. Okay, so let's do an example problem. Let's prove and this example problem is very similar to the problem to example 2 and problems 17 through 22 in the book. Problems 17 through 22 in section 4.2. Just 4.2, yes. All right, so let's do one of these that's very similar. All right. Show that f of x equals x cubed plus x plus 12 has no more than one real root. Now, how do I prove it has one real root? Anybody have anything? We did this in module 1. How do I prove that a function has one real root? At least one. Yeah, IVT. There it is. Right? Those sorts of things make really good final exam questions, by the way, right? We've got something that's got, there's something from module 1 and something from module 3, right? So, those are good, right? Prove it has exactly one real root. That's a good kind of final exam question. Well, let's talk about this one, though. Show that it has no more than one real root. We'll skip the IVT part for the moment. How do you do this? Well, the trick is just to assume otherwise. And that's really the best trick for all of these types of problems. You can do them other ways. But if you assume otherwise, what you're basically going to do is take a pile of spaghetti and you're going to throw it against the wall and you're going to see what sticks. And the point is that at some point you come to a contradiction. Okay? So let's assume otherwise. Let's assume otherwise. Now, if we assume that f has at least two real roots, what are we doing? We're assuming that f of x equals 0 in two places, right? So what we're really assuming, so we assert that there are, that A and B are both roots that f of A equals f of B equals 0. So I'm assuming that there are two places where f has roots. I'm assuming that there are two places where f of x equals 0. I'm going to call them A and B. Okay? How do we feel about that, 1 to 5? That's what I'm asserting. Okay. All right. So I'm assuming that's true. Now, if that's the case, what's true here? If there are two places where f of A, where this is true, what do I need to show to use Rolle's theorem? So I need to show two things, right? I need to show that the function is continuous and the function is differentiable. Well, that's obvious, right? So since f is a polynomial, f is continuous and differentiable everywhere. In particular, f is continuous on AB and differentiable since f of A equals f of B by Rolle's theorem. There exists U in AB so that f prime of U equals 0. Okay, so how do we feel about that, 1 to 5? Okay, now what I'm going to do is I'm going to move from this right here, this statement right here. In particular, since f is continuous on AB and differentiable on AB, I meet the conditions for Rolle's theorem, and I've got this place where f prime of u equals 0. So now let's look at f prime of u. Well, what is f prime of u? F prime of x equals, well, 3x squared plus 1 plus 0. Okay? This is always greater than or equal to 0, right? 3x squared is always greater than or equal to 0. This bit right here, 1, is greater than 0. So this means that f prime of x is always greater than or equal to 1. In other words, f prime of x is always greater than 0. And but u is a perfectly good x. Right? I have a contradiction here. I have something that equals 0 and something that's greater than 0. And I can't do that. It's absurd. Okay? So I've reached a contradiction, and I find out this is absurd, so f may not have no more than 1 real root. So yeah, but the strategy for most of these proofs, and on the in your notes, I actually do want to see some strategies where you add them, and I'll put that on the problem set. But the strategy for all these proofs is pretty much the same. Assume otherwise, right? You assume otherwise, and then you throw whatever you've got on spaghetti, right? It's not just like the other ones where there was like long strategies. No, I'm taking the plate of spaghetti and throwing it against the wall and seeing what sticks. As a matter of fact, I should have an animation of spaghetti being thrown against the wall. If I ever do this again for this thing, there will be an animation going against the screen where the spaghetti sticks to the wall. Okay, that's what should be happening here. That should be the animation that's flying across the thing. Okay. Any questions about that? Okay. 1 to 5. How do we feel about this? This kind of this whole thing here together. I know I'm in front of part of it. So I want to show that this thing has no more than 1 real root, and then I just assume otherwise and ask myself, what's the consequence of that? Yes. So yes, emotes with spaghetti. I really want somebody figure this out. I want on OBS to be able to take a plate of spaghetti. I want an animation. I've seen other people do this, where they have a button where they hit the button and an animation flies with the link. I want an animation that shows a big plate of spaghetti sticking to the wall and then going and seeing what sticks. I think that'd be cool. I think that'd be uber mathy cool. So kind of distinguish myself from the others. Because everyone else, I did a presentation on how to use a green screen to do this, and now everybody's doing it. So now I need something else that's cool. Anyway, it's this constant arms race to keep ahead. You want to be the cool professor. You got to keep ahead of the technology, right? All right. Any questions about that? Okay. It's a tough example, and I will be happy to go over it again with you one-on-one until you understand it, because these are really important tricks. All right, so let's prove the mean value theorem. Okay, we've talked about it a couple times. Let's just go ahead and prove it. So let's see. I need a nice little, statement of the mean value theorem here. Let me go get one. Now, the trick I'm going to use to prove the mean value theorem is also another one that's very important. What I'm going to do is I'm going to create a new function, and I'm going to call it h, and I'm actually going to follow, heaven forbid, you're going to follow something in the book. I'm actually going to follow the proof that's in the book. And the proof that's in the book is in here on page 213 in section 4.2. If you don't have a book, if you're using that, wonderful online web-assigned ebook, which doesn't have page numbers, it's right after the statement of the mean value theorem. He proves it right before example 3, which is on the table of contents. All right, so let's prove this thing. And as I said, we're going to try to use the proof that's kind of in the book. Okay, and the proof, the trick that he's using, the trick. Define an h of x so that I can use Rawls' theorem. Okay, so what I'm going to do is I'm going to define a new function so that I can apply Rawls' theorem to that new function. Okay, and the first time you see this done, it's kind of tricky. All right, and I don't want to intimidate you here, but we can do this. Let's go ahead and do it. Okay. What my new function is going to look like is this. Okay, I'm going to define h of x what I'm going to do is I'm going to take f of x, and then I'm going to subtract, and this should be a defines, by the way. That little colon equal sign means defines as, all right? And you can just use an equal sign. I think the book uses an equal sign. A colon equal sign says this is mine. You don't really have to say it, but it does communicate a little bit more. And don't get locked up on that. What I'm going to do is I'm going to take f of x, and then I'm going to subtract the secant line. In other words, what I'm going to do is I'm going to take f of x, and I'm going to subtract f of a plus MAB times x minus a. Okay, so I'm going to take this. I'm going to take the equation of the secant line here. Is everyone on board with that? I'm taking the equation of the secant line, and I'm just going to subtract it. So my strategy here, okay, my strategy is going to be okay. That's going to be kind of my strategy that I'm going to take to do this. All right, let me show you how it works. Okay, so let h of x be defined as the function f of x minus s a b of x equals f of x minus f of a plus m a b times x minus a, which is the same thing as f of x minus f of a. Oops, I'm off the page, aren't I? Which is the exact same thing as saying f of x minus f of a minus f of a minus f of b over a minus b times the quantity x minus a. Everyone on board with that? Okay. 1 to 5, how do we feel about that? You know, that spaghetti emote in chat is actually making me hungry. So I think I'm out of spaghetti. I'll make some later. All right, so what I've done is I've defined this new function, and I see that we're not happy about that. What I'm doing is I'm defining a function, okay? What I'm doing is I'm defining a new function, and the function, oops, so what I've done here is I'm defining a new function, and here I've got a here I've got b, here I've got this thing here, f of a minus f of b. And what I'm going to do is I'm going to subtract the line from the function, okay? And by subtracting the line from the function, And by subtracting the line from the function, by subtracting the line from the function, I'm going to wind up with this place, okay, where I'm going to wind up with this place. I'm going to wind up with f of this new h of a is going to be equal to h of b. Okay, so let's see that. Okay. So let's put in h of a, and then you'll see it. So then I get f of a minus f of a minus f of a minus f of b. I don't actually care what these numbers are, really. Okay, so now what's going to happen here? Well, oops, that should be an A. So now what happens is that this equals 0, and this bit here equals 0. I don't care what that thing is, right? I don't care what this piece is because it's being multiplied by 0. Right? It's about to be multiplied by 0, so I don't care. And so what I wind up with here is 0 minus 0 equals 0. So, so it should not be f of x minus f of a, because what I'm doing is I'm evaluating h of a. I'm evaluating h of a here, okay? So wherever I see an x, I'm going to substitute in an a, okay? So h of x is this function here. I substitute in a, and I get f of a minus f of a, which is just 0, minus this thing, who cares, because this is now multiplied by a minus a, which is 0. Okay? 1 to 5, how do we feel about that? Okay. All right. Likewise, h of b equals f of b minus f of a minus f of a minus f of b. Did I mess this up somewhere? I should have written this as f of b minus f of a. That may be the confusion. Is that the source of confusion? The fact that I wrote that backwards? Okay. I'm trying to stick to the one in the book, and the book writes it that way, so that may be part of the confusion. Let me write this like this. Now, I'm doing h of b, so this is going to become b minus a, right? For everywhere there's an x, I'm going to sub in a b. And everywhere there's an x here, I'm going to sub in a b, okay? Because I'm taking h of b. Okay. Well, these two terms here are going to cancel, and they become 1. So what I'm left with is f of b minus f of a minus the quantity f of b minus f of a, which equals f of b minus f of a minus f of b plus f of a. And that all equals 0. So I know that h of b okay. How do we feel about that? 1 to 5. That's not an easy thing. All right. I got better numbers on the first class, so maybe y'all should watch the stream for that one for that little bit because maybe I did a better job explaining it. I didn't do the graph, so maybe that's a little bit confusing. Anyway, I now have something where I have h of a equals h of b. All right. I also have this fact. Okay, does anyone have any questions about that step, right? I'm just saying that since f is differentiable and continuous, I subtract the line and I get something that's differentiable and continuous where needed. How do we feel about that one? Any questions? Okay. So what I've got left then, I can use Rolle's theorem. And so there is a place where f prime of u, h prime of u equals 0. Now, the question is what's h prime of u? All right, so let's go back and do h prime of x. H prime of x equals d over dx of f of x minus f of a minus something which I'm going to call MAB times x minus a, which equals the derivative All right, let's look at this. MAB is a constant and f of a are both constants. And that one's a constant multiple. Okay, it's a constant being multiplied by x. So what I have here is that the derivative is f prime of x minus ma. All right, I got a constant multiple. That stays. It's being multiplied by x. So by the power rule, I get x to the 0 there, and that's just 1. And I wind up with f prime of x minus mab. Okay. And I know h prime of u equals 0. Okay. And you have to go through this proof a couple times, but that's the whole thing, right? The big trick here is to invent my h. So the big trick here is to invent this h. Okay, it's not really a rabbit because it's not something that's multiplied by 0. It's another magic trick, right? I'm creating an h that I can then apply that to. Okay, 1 to 5, how do we feel about this proof? So 1 to 5 for the whole proof. And are there any questions about it? Scroll down, yes. Okay. So again, the whole trick was to create this h that would make it work. Okay. All right. Any other questions, comments, issues, suggestions, and thoughts? Okay. Excuse me. I don't have Corona, or maybe I do. I'm out of Corona too. That's the problem. I got to go to the store. But you know, I got a little bit of a out pollen allergy. Okay. I got f prime of x minus m. There's a question. I got this because taking the derivative, okay? So I took the derivative of what h was. Well, h was defined as this thing. So I take the derivative of this thing, and I've got a bunch of pieces here, okay? So, yeah, but it's part of the joke, so leave me alone. So I've got all these pieces here. This piece right here is a constant. Its derivative is going to be 0. This is a constant multiple, so it's going to hang out. And this right here is just a constant, so its derivative is 0. So when I take the derivative, I wind up with f of x minus 0 minus mab, right, times x to the 0, which is just 1, plus 0. Okay? And then I take h prime of, I know that h prime of u is 0. So I take h prime of u, I set it equal to 0. That's going to equal f prime of u minus mab. And if 0 equals f prime of u minus mab, if this part right here, right, if that part right there is all equal to 0, that means that f prime of u, I add 0 to both, add mab to both sides, and I wind up with that f prime of u equals mab, which is what I wanted to show. So there exists I'll put the QED down here. All right, that's what I wanted to show. Any other questions? Okay. That's how you prove the mean value theorem. There's one more major proof, and it's this. Okay. Let's see, do I have, yes, I do. All right, so I'm going to go a little bit over, but I started late because I went over last time, so I'm running like 5 minutes behind, and I'm sorry about that. If you have other classes to log in on, you're going to have to run across campus or down to the fridge, as it will be, and make your next class. Okay, so there's one more major thing, and that's if two functions have the same derivative, then they differ by exactly a constant. Okay? Theorem. Okay. Then there exists the C, there exists some real constant. Then there exists this constant C, so that for every x and d, g of x equals f of x plus c. In other words, and this isn't a name theorem, in your book it is called Corollary 7 on page 215. And the book does a proof with 2 steps, okay? I'm going to do one big proof by assuming otherwise. This is an extremely important result, okay? This is what we need, this result in order to prove the fundamental theorem of calculus, which is where the whole class is heading for Module 4. So one of the last things we're going to do in class, and one of the big things we're going to do in class is we're actually going to prove the fundamental theorem of calculus. And we need this theorem to do it, okay? In other words, functions with the same derivative are vertical shifts. In other words, the shape Okay. In other words, functions with the same derivative have the same shape. And this is a significant result. One direction's obvious, right? If I have two functions that differ by a constant, right? So if I have x cubed, let me see if I can zoom this in for you here. Yeah. So if I have x cubed minus 6x squared and x cubed minus 6x squared plus 5, right? These are going to have the exact same shape, right? Same thing. If I do 3 here and I change this constant here to a 3, right, I wind up with derivatives that are just shifts of each other. And it's obvious one direction, right? I take the derivative of both these functions, I get the same thing, right? I take the derivative of both of these functions, I get 3x squared minus 6x. Okay? Um, and again, this is corollary 7, so this is a consequence. He calls it theorem 5, equation 6, and theorems and corollary 7. I'm calling it all one thing. Okay? And the proof is just one thing. Okay? Now, here I'm going to do the same thing I did before, but I'm also going to assume otherwise. I'm going to find a contradiction. Okay? And it's a little bit slick. Okay? Here's the proof. Okay. Might help if I actually brought up the window, right? All right, so here's the proof. What I'm going to do is I'm going to set at h. And I'm going to let h be one minus the other. And there's something I'm going to assume here. Is everyone on board with that? 1 to 5, how do I feel about that? Okay. All right. Okay. Assume otherwise. So I'm going to assume such a C does not exist. Okay? In other words, and this is the kind of slick part to this. In other words, assume that there is an A and B where G of A equals F of A plus C, but G of B does not equal F of A plus C. Okay? So I'm assuming that there's some place, not F of A, F of B. I'm assuming that there is some place where F of A and F of B, the difference between F of A and F of B is non-zero. In other words, okay? And this assumption, this is kind of a weird thing to assume. So let's just talk about it. Now, what does this thing look like? Anyone want to hazard a guess where this is going? Okay. So here's, by the way, is the kind of visual that's going on here. What I'm asserting right here is that all of these green arrows are of C height. Okay? So by saying that they're not all of C height, I'm saying that there's one that's not. And I'm calling that place B. And I'm saying that there's one that is, right? I'll take the difference between f of A, I'll call C the difference between G of A and F of A. And then I'm saying there's a point where that thing's not equal. Okay? In other words, I've got a point where G of A minus G of B does not equal F of A minus F of B. All right? In other words, I rearrange this. In other words, I've assumed that there's a place where H of A minus H of B does not equal 0. How do we feel about that 1 to 5? And it's a little tricky. I'm doing something that's a little slick here. Okay. Of the people that are still watching, most of you have put up a 3. And I know I'm 10 minutes over, and I'm sorry about that. You're more than welcome to turn it off and watch it later. All right. All right. Well, what's going on then there? Now, H is continuous on the. Okay, so here what I did, I have G of A minus G of B does not equal F of A minus F of B. And then so I scoot this over here, and I scoot this over here, and I wind up with a plus. And then I want to factor out a -1 of this, so I distribute that, and I wind up with a negative in front, G of B minus G of F of B. And that right there is the definition of H, which is what I want, okay? So that's what I did there. There's a bunch of little algebra stuff going on there, which is a little confusing, I understand. Okay. Notice since H is differentiable on AB and continuous on AB, by the MVT, there exists U in AB so that H prime of U equals H of A minus H of B over A minus B. Okay? And since A minus B So my two contradictory statements are this one and this one, which you can't see. How do we feel about this one, 1 to 5? This one's tricky. It's a very important proof, though. Let me say that again. It's a very important proof, though. So how do we feel about it, 1 to 5? I seem to have lost my 1 to 5. Oh, there it went. Okay. Okay. All right. I have some people that are good on it, some people that aren't. I could talk about it again. There's a different version of this proof in the book, but it requires 2 parts. This one only requires 1, and it combines these 2 ideas. So you can use either proof, but if you do use the one in the book, you also have to prove the theorem that he calls Theorem 5, right? So if you do the one in the book, you have to prove Theorem 5 and then Corollary 7 both together. Whereas what I did was I proved them both at the same time. Okay, so that's what I have for today. I'll bring it back down in just a moment. Again, we went over Rawls' theorem. We proved the mean value theorem, and we used the mean value theorem to prove that 2 functions with the same derivative differ by a constant. On Friday, I'm going to start optimization, and then on Monday, I'm going to do. And then I'm sorry, not Friday. On Wednesday, I'm going to start optimization. On Friday, you're going to have optimization and peer leading. On Monday, I'm going to do a little L'Hopital's rule, okay, which is a consequence of the mean value theorem. And I've already introduced that once. And then I'm going to do more on the, and then I'm going to do more optimization problems. And then on Friday, we're going to finish L'Hopital's rule if there's anything I don't finish on Monday. And then we'll start, I'm sorry, not Friday, on Wednesday of next week, I'm going to finish anything in L'Hopital's rule that needs to be done. And then I'm going to do a piece of the extreme value theorem, a consequence of the extreme value theorem that we need for section 4. And we'll look at one of these functions called the area under the curve function. Are there any more questions? And I know I'm over time. I'm like way over time. So I spent too much time talking about the test, which I thought people wanted because they were nervous about the thing. Okay. Any questions, comments, issues, suggestions, thoughts? Oh, there are 2, right. So there's one here, and then there's one here. That h prime of u has to equal 0 because u is a perfectly good x, But I just said that h prime of h prime of u does not equal 0. So you could have this, and if you so desired, this as well. But this is a consequence of that. This right here is a consequence of that. Any other questions, comments, issues, suggestions, thoughts? Okay, well, I'm going to get off Twitch then. I'm going to step into chat, and I will be happy to answer any questions you have, and then I have office hours.